All right, so today's lesson is a continuation of what we just did a second ago. So if you were watching these videos in order, we just did angle problems inside, outside, and on a circle. We're going to go ahead and finish this practice now to just focus on segments inside, outside, and on a circle. So let's focus on the first one. So again, I'm using the same worksheet as our previous video. This is just kind of to help you break it up in terms of angles versus segments. This type of problem, when you have two secants, remember from the previous lesson, a secant goes all the way through a circle and goes out and touches the circle twice. A chord is the portion inside only. So these are two secants. The way that you want to do these problems, we know that these are not angles because I don't have degrees. So I know that these are not angles. So what I'm going to go ahead and do is set up my formula. It is the same on both sides. First thing we're going to do, it's inside plus outside times outside. So 5 plus 3 times 3. Inside, so again, we'll kind of go piece by piece. Inside plus outside times the outside. Inside plus outside times outside equals, and that pattern actually stays the same throughout. X plus 4 times 4. Inside plus outside times outside. So let's kind of talk about it again. If you have two secants crossing outside of the circle, the way that you calculate this is you basically use segment addition. Segment plus segment, inside plus outside times outside. And then the pattern just repeats on the other side. Inside plus outside times outside. So I'm going to simplify. 5 plus 3 is 8. And then I'm just going to bring all this down. 8 times 3 is 24. And then I'm going to distribute. 4 times x is 4x. 4 times 4 is 16. Solving for x, I'm going to subtract 16 to the other side to get 8 equals 4x. Divide by 4. 8 divided by 4 is 2. So remember, the pattern is inside plus outside times outside equals inside plus outside times outside. It is the best for you if you write the equation down. Refer to the circle formula sheet. That has all of the formulas for circles kind of on there, and it should help you narrow down your choices. Now let's make a comparison between this problem and the problem we're about to do next. Okay, we're kind of going to ignore this angle question real quick. So looking at our problems, if we cover this piece up, these are basically the same problem. So notice how we have inside, outside, and outside again. So half of our equation is going to be a duplicate of this. The only difference is now we have a tangent. So let's go ahead and discuss through this problem. So our first piece of our problem is going to remain the same. Okay, it's the same. We're still going to do inside. So inside plus outside times outside. Inside plus my outside times my outside. Oh, sorry, that's looking a little green there. The difference now is I'm involved with a tangent line. And tangent lines are a little bit different when it comes to solving these problems. So with a tangent line, what we're going to do is square it. So in here, this is going to be 15 squared. So the problem is basically the same. Inside plus outside times outside equals the outside part squared, tangent squared, basically. So let's go ahead and simplify. 9 times x is 9x, and we're going to distribute here. 9 times 9 is 81. 15 squared gives me an answer of 225. And I'm just going to continue and solve for x. So subtracting 81. 9x equals 144. When I divide by 9, I get an answer of 16. So notice the similarities between this example and the previous. We still are adding our secant pieces together, but now we're doing tangent squared instead of adding again, because notice how there's nothing inside the circle. So the formula is basically the same. And for our last one, this last one involves chords. Now this looks a little challenging. I don't know why this one always seems to look a little more intimidating than the other ones, but its formula is actually the easiest. All you're going to do is highlight your two chords in your problem. So to start, I'm going to do this chord first. I notice that this section from here to here is 9, and this section is 4x. All you're going to do is multiply them together. 9 times 4x. And then you find the other chord, located here. This section over here is 8, and this section over here is 4x plus 2. And you're going to multiply those together. You're basically just multiplying what is on the circle to itself. So 8, 4x plus 2. So if it's on the same chord, you multiply. And I know that this isn't an angle problem because there's no degrees. Degrees symbols mean angles. No degrees, no angles. So let's go ahead and simplify. 9 times 4 is 36x. 8 times 4 is 32x. And 8 times 2 is 16. Move my 32x to the other side. That says 3x. Let's see. That's why whiteout was invented. So 36 minus 32 is 4x equals 16. I'm going to divide both sides by 4. 16 by 4 is 4. So remember, the formulas, they're not that difficult a formula. The challenging part is just telling the difference between the three.